Hi grade 11s, we are continuing with analytical geometry. This is topic 5 and there's not going to be anything new in this particular video in terms of concepts, but these are the more complex inclination questions. Now in an exam they generally like to ask you one easy one, and then luck of the draw, you might get asked a more complex inclination question for sometimes 3, 4, 5 marks. They actually are really fun questions, and even if you don't get the final answer, they're the type of questions which you can at least get 3 or 4 marks for. So I've got 5 examples that we're going to go through fairly slowly, just to write down notes on all the different things that we can look out for that can help us along the way. So the first question example here, you're given 2 straight lines, you're given some points on those lines, and this question says determine the value of theta, which is between these two. So the moment there is any analytical geometry question with like a theta on it, my mind thinks angle of inclination. So what I personally go and do first is I go and draw in all the angles of inclination that are on the page. So there's an angle of inclination, and I can find that because I know the point C and I know the point B, so it is possible to work out that gradient. Remember, the connection between the angle is through the gradient. Now I can't call that theta, so I'm going to call that alpha. You could call it x, anything you want. And the other angle of inclination in this particular question is the positive graph, which I'm going to call beta. And I know E and I know F, so I can find alpha and beta. So I'm just going to write down that as my first step. I don't always need those, but I like to label in all angles of inclination, because I like to then think about which ones I can actually find out, and I can find out that and I can find out that. So then I like to say to myself, I like to have a plan before I start. So then I say to myself, are these angles connected to the one I want in some way? So are these 2 angles of inclination connected to theta? Because theta is the one I want. Now when I say connected, what do I mean? Well, unfortunately, we've got a whole bunch of geometry that can come in here. So what do I mean by connected? Well, first of all, are there any triangles? Because the moment we have triangles, we have things like sum of angles in a triangle. We have things like exterior angle of a triangle. We have adjacent angles on a straight line. So adjacent angles on a straight line. We have vertically opposite angles. So all of these are things that definitely come up. I'm trying to think, that's pretty much all the ones that I use in analytical geometry generally. So I look out for triangles because I know I can do sum of angles of a triangle. I look out for exterior angle of a triangle, definitely adjacent angles on a straight line, and definitely vertically opposite angles. Now also please know that there's often 10 different ways to get to the answer. So let's just look at this example. If I found alpha and beta, how could that help me? Well, if I found alpha, I could use angles on a straight line to find, and I'm kind of running out of letters here to use this, so let me call this x. Actually, I'm not going to use x. I don't like using x on a Cartesian plane because, there's x coordinates in there is x-axis. So let's call this a. So if I knew alpha, I could find a by doing angles on a straight line. Now, how could that help me? Well, that could help me because then theta is what's called the exterior angle of this triangle, because that is the angle outside, and I could say, well, theta equals a plus beta, because the exterior angle is equal to the 2 interior opposite angles added together. So my plan could be work out alpha, work out a, work out beta, and then get to theta. What other options do I have? Because trust me, there's always a couple. Well, another option would be to work out alpha and then use exterior angle of a triangle, except in this case, could I think of this as the triangle like that, and alpha is the exterior angle. So alpha would be equal to beta plus d. So I could work out d, and then I could use angles on a straight line to get to theta. So there's loads of ways to do this. Basically, I'm pretty much realizing that I have to use angles on a straight line, and then I could use exterior angles. Now, or a third option is I could work out A, and then I could do sum of angles in a triangle to D, and then I could go to theta. Because often people don't see the exterior angle of a triangle very easily. So basically, what I've realized so far is that either way I'm going to do this question, I have to figure out alpha and I have to figure out beta, and then I'm going to have to pick my path. So now that I have a plan, I can start. Now, just before I do that, actually, I think one of the most common misconceptions here is people see the U shape. They're like, oh gosh, there's a U, great. These two add to 180. Now just be careful, that whole U-shaped co-interior angles only work if your lines are parallel, and this line is not parallel to that line. One's horizontal and one's not. So don't forget your basic geometry. Angles are only co-interior, adding up to 180 if the lines are parallel. Okay, so let's start with our plan. Well, first of all, if I need to find alpha, I need to find the gradient of BC. Now, this is where your subscripts, I know I mentioned this in a previous video, subscripts are hugely important here, because we're going to be finding out multiple gradients here, and so being able to tell which one's which is going to be really important. So don't forget, we don't show any substitution, so it's change in y. So 6 minus 0 over 0 minus 6, which is negative 1. Always try and pause and ask yourself if that makes sense. Should this be a negative gradient? Well, yes, it should. So that means that tan of alpha. Now, that alpha wasn't labeled in the question, so are you allowed to use alpha? Absolutely. In an exam, from now on, grade 11 and matric, you're given an answer booklet, and these pictures are pasted in the answer booklet where you answer. So what's beautiful about that is you can label anything on the page, and you don't even have to stay anything. If you just wrote tan alpha equals -1, I'll go, where's alpha? And I'll look at your drawing. So literally you can just label anything on the page you want, and then you can use that, and we will look at the picture. So now that means that alpha equals, now let's just remind ourselves, what we do on our calculator is we do shift tan, so shift tan of -1. Now you're going to get -45, and then we're going to remind ourselves, hang on, can't be negative. So how do I go from that to my answer? Is I add 180 degrees. So I actually get 135 degrees. Now, if I was you, I always go and label in anything that I work out, I go and label in, because you never know when it's going to be needed in future. Okay, now I'm just going to draw a line down my page just so I've got my picture still showing, but you can work underneath. So now what's the gradient of FE or EF? So that's 6 take away 2 over 6 minus 2. So that's 4 over 8, which is a half. So tan of what I've called beta is equal to a half. So shift tan of a half, and I get 26. Now I shouldn't really be rounding off here, because this isn't my final answer. So I try and keep a couple of decimal places, because you never know how other decimals might affect this rounding later on, and then you lose a mark for rounding because you've rounded too early. So try and keep at least 3 decimal places. Okay, so now this is 26,565 if I keep 3. And now there's options, lots of options to do. I think probably the easiest option would be to find A, which is there by adjacent angles in a straight line, and then either to find D or to go straight to theta. I think exterior angles are quite hard to visualize, and so I prefer to be cautious if I need to. So now I will say A equals, and I normally probably wouldn't show this step, I would do that on my calculator, but just because these are notes, so it's 180 minus 135, which is 45. Now, don't forget, any geometry that you use anywhere, in any paper, you have to give reasons. So this is because of angles on a straight line. Now, also remember that they're very strict on geometry reasons. So literally the only thing you can write here is angles on a straight line. We mustn't make up some funny reason like add to 180 angles. No. Angles on a straight line. We will do our geometry section obviously again this year, and then we'll revise these, but no time like the present. Okay, so this is 45, and now I'm going to do two different options. So from here, either you could now go straight to theta, and you could say great. So theta is 45 plus this 26,565, and that would be because of, don't forget, the moment you write down a statement, not at the answer level, at the statement you should say your reason. So exterior angle of triangle, and so that gives me theta is 71, and now I can round off, 57 degrees. Okay, or from this point we could find D. Now D, we would be using sum of angles in a triangle, because we're going to be doing 180 minus that. So I should probably maybe write this below, because I probably won't have enough space. So let me go down a bit. So or you could say D. Again, I wouldn't necessarily write this step. By grade 11 level, we generally do this on our calculator and don't show any working. So I probably would just say 180 minus that. And I should write a reason, and that reason is sum of angles in triangle. Remember, very strict on reasons. So let's try and use the right ones from the start. So I get 108. Shouldn't round off because it's not my final answer, degrees. And therefore, theta is 180 minus this 108,4349, which is 71,57 degrees. And this reason is angles on a straight line. Now, again, just to remind you here, I normally in an exam won't write that. There's nothing wrong with doing both of those in your calculator. It also helps to keep these questions quite short. Now, how many marks would a question be out of interest? Well, one for finding the gradient of each, one for finding the angle of each, and then you'd probably need 2 more marks, because you either needed to find A and then theta, or you needed to find A and D and theta. So this will probably be about 6 marks. So don't let the mark allocation in a question like this psych you out. Often we see 6 marks and we go, oh, it must be hugely complex. This wasn't too crazy, and to be honest, if I get desperate, I just find a whole bunch of angles and then I get some answers and I get some marks. Right, let's try some more. These actually are quite fun. In the diagram below, determine the size of alpha, the angle between the lines BD and AC. So don't forget, my first step is to label in angles of inclination. Now, in this question, I happen to label them in for you. It's luck of the draw what you get given in an exam. So I labeled in beta there, which is one of the angles of inclination, and theta. Could I calculate both of these? Well, yes, I can, because I can find both those gradients. So what I like to do is find a plan of action first. If you found beta, how could that help you? And don't forget, this is where your geometry comes in. So if you can find beta, you can find B. And now I would have sum of angles in a triangle. Now what's wonderful about these questions is that you're going to start realizing that chances are they're all versions of each other. And so you start with the more practice you do, the better you get at these. So I think I have a plan. So the first thing I'm going to do is I'm going to work out the gradient of BD so that I can work out beta. So that's 4 minus 3 all over -1 minus 6. So that's 7 over -7, which is -1. Oh, we've seen this before. So tan of beta equals -1. I would shift tan of -1, and we've seen this exact angle before. Again, these things come up so often, and I get -45. And I know that that's not right, because it's meant to be an obtuse angle. So I add 180 degrees, and I get 135, which is exactly what I got in the previous question, with exactly the same gradient. So this is 135 degrees. Okay, let me do the next. Next thing is I want to find the gradient of AC, which is 3 minus 2 over 2 minus 5, which is equal to 5 over 7. So therefore tan of theta in this case would be 5 over 7. And I can just shift tan of 5 over 7 because there'll be no negative involved. And I get 35,5376. So this is 35,5376. And so, right now I could do exterior angle of a triangle because I could say that alpha and theta must add together to give me 135 because of exterior angle. Again, I think exterior angles can be quite challenging, so I'm going to rather find B, and I'm going to start cutting corners because we wrote down our first example so nicely. So I would say 180 minus that 135 will give you B because it's a straight line. So I would say 45 degrees, and my reason angles on a straight line. And now I can find alpha. Now again, I probably just would write alpha equals, and I'd write down the answer, because on my calculator I'll go 180 minus 35.5376 minus 45 and just push equals. So I would probably go straight to 99,46 degrees, sum of angles in triangle, if I was in an exam. Now, just because these are notes, let's just quite note to ourselves, where did this come from? This came from 180 minus the B, which was 45, and then minus theta, which was my 35,54 really, and that's how I got 99,46. So that's where it came from. So again, probably a 6-mark question, and you really do get better and better and better as you go along. Okay, let's look at example 3. Now, I like example 3 a lot. I chose it for a very specific reason, and that's because it's just slightly different. So it says determine the value of theta. So the moment I look at this, I'm like, okay, well, let me draw in my angles of inclination. That's what I always tend to do. Now, the problem with this is that these lines don't really go through the x-axis, so it's a bit weird. So there's nothing wrong with extending the lines through the x-axis, simply so that you can actually see where the angles of inclination are. So if I take A through C, it didn't extend, and there's nothing wrong with extending it. Why? Because there's my angle of inclination. That's alpha. If I don't extend it, I can't really see my angle of inclination. So by the same reasoning, I'm going to extend that to say that that is where beta is. Now I can find alpha and beta because I can work out both of those gradients. The question is, how does that help me find theta? So, a couple of things. I think that you get really good at this after a while. This is probably one of the most difficult ones to see. So I'm hoping that you can see that there's theta. That is the angle between the red and the blue. That's the angle between the red and the blue. So those are vertically opposite angles. So if I can find the angle between the red and blue on the right hand side of this point C, I can do vertically opposite angles. So that's one way to do it. Okay, what's another way to do it? Okay, I can view theta as two angles added together. Could I view theta? Let me pick a nice color here. Let's use this. If I found beta, I could find that angle there. So that angle there, which I'm going to call B for now, simply because those would be angles on a straight line. Then, if I have a look at this, there's a line and there's a line. That forms alpha there. So, where is that on the other side? That is there. Those are vertically opposite angles because it's from the blue to the x-axis, and this is from the blue to the x-axis. If I draw it a little bit further away, is what I'm arguing is that that is the same as alpha. It's probably easier to see if I draw it far away. I'm arguing vertically opposite angles using the x-axis. I think it's easier if I highlight it in blue, and this blue line. So let me erase the green so that this is a little bit more clear. If you think of those two blue lines, those alphas are vertically opposite. So definitely quite a tricky example, but I think it might be a good idea for us to find alpha and do vertically. Oh, that was not meant to happen. Oh, not very helpful at all. So let me redraw that in. There's no undo button, unfortunately. Although maybe this makes it look a bit neater. So there's alpha. I'm arguing that this is also alpha. Those two are vertically opposite angles. So basically, can I work out theta by dividing it into two parts? Finding alpha and doing vertically opposite, finding beta and then working out b and adding those two together. So let's try and do this a little bit more slowly when we work through it, and hopefully it'll become obvious to us. So we'll have CA's gradient is 0 minus 6 all over 5 minus 0. So that becomes 6 over 5. Now that makes sense because it has to be positive. That is an upwardly sloping graph. So tan of alpha is 6 over 5. So if I shift tan of 6 divided by 5, remember not tan, shift tan, I get 50,1944 degrees. So this angle here is 50,1944. Now that means that this is 50,1944. Now I can't call it alpha, so maybe let me give it another. Let's call it A. Remember, you have these diagrams in your exam, so there's nothing wrong with you just saying A. So therefore A is 50,1944 degrees. Why? Vert, op, angles equal. So that's the first time we're using that reason in this video. Okay, next one is, can I find beta? So let me use this one, this color. So can I find the gradient of BC, which is 2 take away 0 over 0 take away 5, which is negative 2 over 5. So therefore tan of beta is equal to negative 2 over 5, and this is the negative one. So shift tan of negative 2 over 5 is negative 21.80, but I must add 180. Something we should be getting used to. So beta is 158,1985. So that's this 158,1985. So how am I going to find little b? Little b is going to be 180 minus that because of angles on a straight line. So 180 minus that 158, I get 21,8014 degrees, and that is angles on a straight line. So basically I now know that angle there, and I know this A here, so basically I can add them together for theta. Now I won't need a reason for this because I've found out the two parts and I'm just adding them up to equal the answer. So my two parts added together, and hopefully if you don't round off early, you get the right answer. So now I can round off and I get 71,995. So let me just write this down for you to see. Now that means I'm going to get 72 because that 5 rounds the 9 and that rounds up to 10, which rounds the 9, which rounds that. So that's pretty nifty. Now this is a pretty good example of showing you what happens if you round too early. This here, if you round it off, would be 50,19. And this here, if you round it off, would be 21,80. And when you add those together, you get 71,99. And so you would be penalized for early rounding because you actually don't get the same answer. Now what happened here is actually this 4 and this 1. You see these third decimal places actually added together, which caused your third decimal place to push above 5. So that rounded my second, which then rounded my first. So often your third decimal places add together to cause a rounding later on. And so if you round too early, you miss that out. So that was a great example of that. Okay, let's look at another example. Example number 4. We've got 2 more to go. Example number 4. Can you find the size of PMN? Well, first of all, we've discussed this before. let me label in my angles of inclination. So that would be alpha. I can work out alpha because I can work out that gradient. This would be beta. I can work that out. I can work that out. And then I could do exterior. I mean, we've seen this exact type of question before. I could use exterior angle of a triangle, or I could work out that and then do sum of angles in a triangle. So that's fairly boring. So I want to show you a different way to do this question, simply because sometimes you need this method. And so I'm going to do this a different way, and I encourage you to take down this note of the different way of doing it, simply because some questions require you to have this skill. Now, what am I talking about? The angle of inclination, we defined it as the angle anti-clockwise from the x-axis to the line. Now, I said the word x-axis in the definition, and the truth is it can be the angle anti-clockwise from any horizontal line. So, for example, if I drew a horizontal line in there, that would also be alpha. Now, think about it. Those are parallels, so these are just corresponding. So, basically, an angle of inclination we generally draw at the axis, but the reality is you could draw in any horizontal line and label in an angle of inclination. So, sometimes I draw in what I call the phantom x-axis. So, if my angle is at this point M that I'm interested in, I sometimes draw in a phantom x-axis there. Now, why? Because if I extend this line, that is alpha. Now, that should be fairly obvious to me because these lines are parallel, and so those alphas, they're corresponding. So the angle of inclination is the angle anti-clockwise from any horizontal line, basically. Now, if I continue this line over there, that is beta. Now, why does this help me to often use this method? Sometimes you're forced to use this method because there are no triangles for you to work with, and so you're kind of forced into it. Sometimes it's actually just faster. So if I draw in, now I call this the phantom x-axis, so I'm just going to write this in. I call this the phantom x-axis, and the idea is, and I'm going to write this down as well, an angle of inclination is the anti-clockwise angle from any horizontal. An angle of inclination is the angle anti-clockwise from any horizontal line. We just always say the x-axis, but any horizontal line will be fine. So you can always draw in a phantom. Now, how will that help me? Well, my argument is if I take alpha and I take away this beta, I'll get that angle there. And that would be vertically opposite. So I'm going to find out my gradients, and I'm going to find out alpha and beta. And because I've drawn this on my drawing, I don't have to explain the phantom x-axis or anything. So my memo could simply say my gradient from M to N is equal to 4 minus 2 all over, and that looks like a 2 now that I've drawn all over 2 minus 3. So that's 6 over 5. So that means that tan alpha is 6 over 5. So shift tan of 6 divided by 5. Now this angle should ring a bell because we've actually done it before. So it's 50,1944. So that's alpha. So that's there. That is 50,1944. So now I'm going to find beta. So my gradient of MP is equal to 4 minus 1 all over 2 minus 9. So that's 5 over 11. So tan of beta is equal to 5 over 11. So shift tan of 5 over 11, and beta equals 24,4439. So this is 24.443. So now if this was me in an exam, I'd just put a letter here. I'd say that this is, I don't know, D. So then I'd say therefore D, and I'm taking alpha and I'm subtracting beta. Now I don't have to explain that because the one is just, it's the angle between these two angles. So it's nothing I need to explain. There's no geometry reason for that. So D is 25,7504 degrees. And now that's perfect because I can go vertically opposite to the one I wanted. So therefore PMN is 25,75 degrees. And my reason, vert op angles equal. So this is the phantom x-axis idea. Really, really, really useful. And you can just draw it in on your picture in an exam and you have to give no explanation. Now, just to show you where else this would be useful, what happens if I asked you for that angle there? Now, that angle there is not in a triangle. That's not a triangle, and so it starts to become very confusing. So if I had to find that angle there, there's nothing wrong with drawing in a phantom x-axis. That is alpha. That's another angle of inclination, and then you could, we'll call that gamma, and then you could do some more subtraction. So keep this idea of the phantom x-axis in your mind all the time. Right, I know this is a super long video, so take breaks when you need. Last question. Example 5. Now the reason why I did this, I would probably never do this to you in an exam ever, but lots of textbooks do. Calculate BAC given ABC. Now they haven't drawn it for you, so it simply means that you have to quickly draw it. Now we don't draw it completely accurately, but vaguely. So 1, 2 would be round about there. Negative 3, negative 2 would be, I don't know, round about there. And 3, negative 6 would be lower. So there's C. So let me label in those coordinates. Negative 3, negative 2. And there's my triangle. Not particularly well drawn, but we don't have time in an exam to draw nicely. And so they've asked you for that angle there at A. Now, that's actually really nice because we've done lots of these before. So maybe hit pause and try this one for yourself and then watch the memo. So hit pause and try it. Okay, I'm trusting that you've hit pause and tried it. That to me is going to be alpha. It's an angle of inclination. That to me is going to be beta. That's the angle of inclination. And then I've got a wonderful triangle. So I'm going to hopefully move through this quite quickly. So I need the gradient from A to C, which is 2 minus 6, all over 1 minus 3, which is 8 over negative 2. So that's negative 4, I think. So tan of alpha is negative 4. So shift tan of negative 4, but then you need to add 180. And I get alpha is equal to 104,0362 degrees. Now I'm going to go and find the gradient of AB. So that's 2 minus 2 over 1 minus 3. So that's 4 over 4, which is 1. Now I should know this. If tan of beta equals 1, shift tan of 1, and I get 45 degrees. So this is 45. Now I could use exterior angle of a triangle and go straight to my answer. Or if I wanted to, I could do my adjacent angles on a straight line. So I could say A would be, and that would be 180 minus this 104.0362. So I could get 75,9638, and that would be angles on a straight line. So that was 180 minus that. And now I'm going to do sum of angles in a triangle. So BAC, I probably wouldn't show any working. I would just do 180 minus that 75 minus the 45 on my calculator and go straight to 59,036, so 0.04 degrees, and that is sum of angles in a triangle. So other than the two in the middle, which were quite tough and interesting, you'll notice that questions 1, 2, and 5 are all around the same thing. So, super long video, a lot to take in, definitely the most complex thing in the whole of grade 11. It's kind of downhill from here. So, well done. Definitely worth practicing. Keep going.